2NURFM.com, a broadcast service of the University of Newcastle.
Joining us today, Professor John O'Connor from the University of Newcastle, talking the possibility of a ninth new planet. John, Happy New Year. Nice to see you.
Thank you, Meryl.
Now, we've had to ditch Pluto, haven't we?
We grew up with 9 planets and one's been downgraded, demoted.
I think that's very sad, although it would have been easier when I was doing all of those school projects. Anyhow, there is the possibility that there could be another ninth planet on the way.
That's right. The process has been one. We haven't found it yet, but we've had, I'm not part of this, but they've found very strong evidence for it. Now, this is not new, and many years ago we knew the planets out as far as Uranus, but the trouble is Uranus wasn't following its orbit properly. It was actually getting disturbed by something, and they worked out mathematically there must be another planet out there, and sure enough they worked out it's roughly its size and where it was, and it was found. It was Neptune, and now Neptune is our most distant planet. There have been suspicions for a long time that things aren't quite right out there, that there might still be something else beyond Pluto. Pluto was downgraded because it's not big enough, doesn't have enough influence. But it's only been recently that they've been looking at a number of the objects which are in the Kuiper's belt. Now, the Kuiper's belt is a bit like that belt of asteroids between Mars and Jupiter. It's a collection of big rocks and things, anything up to the size of Pluto, just wandering around, orbiting the solar system. But they found that a number of them are following a very similar path, and they all pass through one particular area. And it would be very strange for that to happen by chance. In fact, 0.007% is the probability that that's a random occurrence.
So what does it mean, though, that the fact that they're all sort of tracking around?
Well, it means there's something shepherding them. Okay. And so what they did was they ran a whole system of computer programs. They initially thought there might be something big which was following the same path, and they were all sort of wandering along like sheep. But that didn't quite come up with the right results. However, they could model it very well by having something that was going through that collection. So imagine a collection of things like bangles around your wrist. Mm-hmm. They're not all in parallel. They're pointing in different directions. What's happening is that this very large planet, they can actually model what's happening with all of those Kuiper belt objects if it actually goes through the centre and swings around and keeps coming back through the centre of all of those bangles. Now, this thing, by their estimates, optimising the models and really homing in to make sure they could explain everything, turns out to be something which is about 20 times the mass of the Earth. So it's a fairly solid thing, much bigger than Pluto. In fact, it's about 5,000 times the size of Pluto. And it's got a very long orbit. It's about 20 times as far out as Neptune, which is the most distant object.
So what sort of orbit time are we talking about there then?
Until they find it, they can't be sure, but it's in the range of 10 to 20,000 years.
So it's very slow.
It's moving around quite leisurely out there. And it's interesting that something on that time scale can still shepherd all of these, this whole collection of Kuiper belt objects. And it's actually got them into a nice little resonance and then nice pathway. And they've now got a handful of these objects which are all behaving in this particular way. I think 8 from memory, but they're still looking. And so now the big challenge is, how do we find it? Why haven't we seen it already? I mean,
if it's so big, that's the question.
That's right. Well, it's not really that big, and it's a really long way away. I mean, we have difficulty seeing the planets. I mean, we don't see all the planets with the naked eye. The problem is they've actually searched for other objects, but not that far out and not that dim. So they've actually got to look at a slightly different wavelength. They've got to do a new search. And so that started. They started the challenge to see if they can actually see this. The interesting thing with Neptune was that it was actually observed several times. Even Galileo observed Neptune, but because it was in a particular part of its orbit, it didn't seem to be moving, so he thought it was a star.
Okay.
And other people saw it in one-off hits. But it was only later, when they worked out what Neptune was, that people went looking and carefully identified that it was a planet. So it's not going to be easy to find. It's a long way out. It's very dim. But certainly we have the telescopes that can do it. And they're now on the search. And it could take years. But it'd be interesting. We could go back to having 9 planets.
And hopefully, whomever it is that discovers this planet, they'll be more easily believed than poor old Galileo was. Can I ask you, just in closing, John, and we're chatting with Professor John O'Connor from the University of Newcastle today, do you think that there is another Earth out there with other beings on it? I know that's the worst question in the world to ask a scientist, John, but do you actually think that there could be?
Well, I think we should talk about this next time. There's a thing called the Drake equation, which is an attempt to try and work out the probability that there is another civilization out there. And there are a lot of variables in that, things that we don't know very accurately, but it comes out that there might be. And so I think we need to go through that. What are the parts of that equation? Where are the unknowns? And even if there is life out there, the chance that within our civilization's lifetime we come across them could be very small. So even if they're out there, we may not actually ever encounter them.
Asking all the big questions. In a fortnight's time, we'll attempt to answer them and take off where we've left off today with the Drake equation. Professor John O'Connor, thank you, and you'll have my mind wandering now.
Thank you, Meryl.
We'll join him again in a couple of weeks. It is interesting to think, though, isn't it? You know, it is such a massive place. And who knows, there could be someone else out there playing great songs like this one from Foreigner. 2NURFM, Meryl Swanson keeping you company.